Okay, I'm going to do a quick video on solving literal equations. So when we solve literal equations, we're solving for a specific variable that it tells us, or that the directions tell us to solve for. Literal equations are equations with variables, with letters. So as you can see, there's no numbers there, only letters. So what we want to do is we want to solve for one of the variables. So this time we're going to solve for n. So when you solve these, you treat them just like you would any equation with numbers. You just got to remember all your rules. If we're solving for n, and it's next to r and t, that means multiplication. So think of those like a coefficient. And if it was a coefficient, we would divide by it. So couldn't we just divide by the r and the t? And it'll work. And now we flip it around. And we have n equals pv over rt. And that equation is solved for n. So now let's do a little bit harder one. This one's the area for the trapezoid. This is the formula for the trapezoid area of, I cannot get it out. This is the formula for the area of a trapezoid. Could get that sentence out. So what we want to do here is this one we're going to solve for h. So when we solve for h, the first thing I see there that I want to get rid of is I want to get rid of that fraction, like we learned in the previous video. And so since the denominator is 2, and that's the only fraction, then 2 is what we're going to multiply by. And this is considered one big term. This expression is in this parentheses, it's protected, so it's basically multiplying to everything else, so it's one big term that you're going to multiply 2 by. So this is going to be 2a. This is going to cancel the 2's, so you're left with, that's 1 and an h, but you don't need the 1. It's an understood 1. So we have the rest of the equation. So now we still want to solve for h. Well, remember, it's just like the one before. H next to this parentheses, they're multiplied. So it's kind of like having a coefficient in front of h. It's the same concept. So same thing as we did before. We divide by it. And we divide both sides by it. So now it cancels off that side, and now we've isolated h. And I'm just going to flip everything around. And there is your solved formula for the height. Okay, so when do we use literal equations? Why is it important to learn them? Well, when you are working with linear equations, which more specifically you may remember learning the slope-intercept form in Algebra 1. So that's when we use literal equations a lot. When we need an equation, like this one right now is what we call standard form of a linear equation. We want this in slope-intercept form. So that means it needs to be solved for y. Because if you remember, slope-intercept form, y equals mx plus b. That's its standard form. So we need it solved for y. So that's what we use literal equations for. So now if I need to solve for y, I need this term gone because I need the y term left. So I need to move this first. So this is a positive 2x. I'm going to subtract it. Now normally you would bring it over here and you would line it up with your constant on the other side. But the problem with that is those aren't like terms. This is a constant, this is a coefficient term. So you can't actually subtract them, so we're just going to write them next to each other. And then in proper slope-intercept form, your x term comes first, and then your constant term, which is your b, comes second. So that's what it's going to look like. And now we have one more step because we have a coefficient. And remember, we're isolating y. That's what we're solving for because we want it in slope-intercept form. So this time, because we have multiple terms, because we have another variable over here, we want to divide every term by 3 to isolate y. So y equals, that's going to be negative 2/3 x. And if you remember, that's m. that would be your slope. Your slope is negative 2/3. And then plus 12 divided by 3 is 4. And that is why literal equations are important to learn. All right, thank you.